Hello everyone, welcome to today's show. This is the first episode that I am releasing for a while. I have been taking a little bit of vacation. I'm glad that you're still sticking with me, and from now on I will release a new episode every 4 days as usual. And today we're gonna talk a little bit about a network mapper. I'm gonna create the tool, which I'm gonna call netmap, and it'll be a network mapper. So what is a network mapper? There is something called a port scanner, which is basically the same, but the port scanner is like a black hat hacking tool. This is a security tool that we're gonna create today. So port scanners are primarily used by hackers to map a network and find out what ports are open, like TCP ports most often. And a network mapper is used by sysadmins and security people to check the network if there are any ports open that shouldn't be, and perhaps you are new at your job or you're taking over a network that you need to learn. Then it's a good way to map it using a network mapper, so you know what servers are up and what services they are running and so forth. So basically we're going to code something that works something like this. You run a netmap and you give it a starting IP address like this, and an ending IP address something like this, and then a port number, for example 22. So this means that it'll start with this IP, and then it will take the IP with a 2 and 3 and all the way up to 200. And it will make connections to each and every one of them at TCP port 22, which is the SSH. If it's unable to connect, the port is not open, or it's firewalled, or the server is down, or there's no server with that IP address, and then it'll do nothing. But if the port is open and the connection succeeds, then it will log that. So basically it will connect to that, and I can show you. If I connect to localhost at port 19 in this case, the regular port for SSH is 22, but I'm using 19 on my server primarily to don't show up on network mapping for port 22. Okay, I'm not using that IP. Let's see. Let's connect directly to the external IP address. Let's see. Okay, I think I'm binding it to this 10 address. 10.123. 10.123. No, let's check. Port 18. Right. There we go. So when I use telnet, I basically create a TCP connection, and this is what the server is sending to us when we connect on that port. So it basically says what SSH version it's running, and we want that information. So we're going to log that the port is open, and if we are able to get the version of the SSH running, we want to log that as well. And we are going to create several versions of this network mapper. The first will be a very naive version. So version 1 naive, it's gonna have a no threads, and it's gonna use blocking sockets. So what are blocking and non-blocking sockets? Well, when you this far, if you have watched my earlier videos about TCP connections, we have basically always used blocking sockets. That means that there is no concurrency. So we use connect to connect, and it'll wait until the connection is established, and then it will continue the program flow. And when we read data, we use read, and it will wait until there is data to read, and then it will terminate. And same with the write. It will write the data and then terminate. And that is the default behavior, and it's very easy to code using that technique because you don't have to worry about concurrency and stuff. In many cases, this is what we want, but for network mapper, no, not really, because it will be very slow. We have to wait possibly minutes per IP address if it's unable to connect. But it's good to create the most naive version first, so we can see what we can improve. The second version will be like the naive, but with non-blocking sockets. So still no threads, but with non-blocking sockets. So that's basically, if you know JavaScript, like using async await, you can do concurrent stuff with non-blocking sockets. So when you do connect, for example, it will terminate instantly, even if it hasn't connected yet. Same with read. It will, if there is no data to read, it won't read anything, it will just terminate. And if there is data to read, it will read it. And basically same with write. So we need to develop a system that will check all the open TCP connections. So basically we do a lot of connect to different IPs, and these calls will terminate instantly. Then we want to use the select syscall, basically to watch all these open connections. So select will wait, and when there is action on any of these socket file descriptors, then it will terminate. And we can use a macro to check which sockets are, well, that's something is happening to. And the only thing it can happen, it's basically two things. It can fail and it can succeed. So if we have any action on the sockets, then we can do the connect, and or then the connect will succeed and we have an open TCP connection. And then we can use select to check for the open sockets as well. And when there is data to read, select will terminate. We can check with a macro, and then we can call read on the sockets which have data to read. So this will make it much faster. And the third version then we'll use the real concurrency with threads. And I think we are going to use my library, needle threads. So this time we'll have threads, and we're gonna have non-blocking sockets. Which basically means that when we have connected successfully to the servers, then we can create a thread which will wait for the actual data. And that will make it even more faster, plus it will make things easier for us because we don't have to worry too much about reading every open socket with select. Only the initial connections will be that way. And perhaps we will even do a fourth version sometime, and then we can do maybe a scene scanner. That's basically when we use raw sockets. So we can send, we can alter the IP packets in any way we want and edit the headers and stuff. So we can basically send a lot of TCP SYN requests to the different ports and then collect the SYNAC responses from it. And this would make it incredibly faster. But we will focus on the first task today, creating a very naive, easy to write network mapper, which will be very, very slow, but it will work. And this first version shouldn't be a problem even for beginners to write. Those will be a little bit more advanced, but we'll worry about that when we get to that point. So, I'm also going to be a little bit structurized because today I'm going to need to write a function to convert between IP addresses and well, basically it will use this format and turn it into a number so we can work with it with the sockets, and the other way around. And I have written that function twice already, I think. So this will be the third and last time. I'm going to create something which I'm going to call Birch utils, which basically will be my library for utility functions. So each time I will write a utility function that I might have use for in other situations, in other projects. I will add that utility function to the library instead. And we will build on that library and add stuff all along. And then we can be very effective when we have all the utility functions written and in one place. And this is an idea that I recommend to all of you, because you are probably like me, that you are rewriting a lot of functions. Perhaps you're copy pasting. I'm not very fond of that, but you can do that as well. But I recommend create your own library and add all your utility functions to that library. So I'm going to create a new screen, and I'm going to go into my code, and I'm going to create Birch utils. I'm going to set my home to this directory, and I have already in VS Code opened the network mapper file through Sociopath, directly connected to the server. But one nifty feature is you can go into another directory. So I'm currently working against the netmap directory. But if I go to my code and I go to Birch utils and I open this in editor, then it's going to connect, and it will create a new window like this for this Birch utils directory. But one nifty thing with VS Code is you can take this directory and put it here, and then you click add folder to workspace. So I can close this one down, and now I have both my directories in the same place. And when I create files or edit stuff, Sociopath SCP will update all the files for me. Okay, so let's begin with the make files. I will begin with the birch util make file. Create this make file. And what do I need here? That's kind of big. I hope this will work for you. Let's see. We want some flags. And I'm going to use 03 for optimizations. I'm going to use wall. And I'm going to use the C standard C2X. Like this. And perhaps we're going to have some LD flags as well. I'll leave that as is. And what are we going to do here? We're going to have a, let's see, we're going to want to create a O file first. So this will be birch utils.o, which depends on birch utils.c. And then, no, not C2X. And in order to compile this, we're going to run cc with some flags and -c, and we're going to take the source file like this. When we have an O file, we can create our library file, which is so, which depend on the birchutils.o. And in here we're going to run cc with the flags, and we're going to take the source file and compile it to the target file, like so. I also want to have, let's see, I want to have clean function which will remove birch utils.o, birch utils.so, and all will be first clean and then birch utils.so, like so. This will work, I believe. We do need a couple of additional flags because we're creating a library, and I always seem to forget those flags. So let's see. Let's go into the files and directory and our library and libarc-force makefile. So these wall fpic share ldl and gnu source. And as you see, the makefile has been uploaded automatically. So let's add that to the flags, like so. And now we have a makefile. So if we do create this, let's see, I want to have a birch utils.h, and I want to have a birch utils.c. And I need to save. Let's see, where were we? because it uploads every time you save. Okay, so if I run make, it will create our file like this. Okay, so that's the burst utils. We're not going to worry about that for now. It'll be when we are dealing with IP addresses. So let's do the same for this network mapper thing. In this case, I will create netmap. Let's see how we're going to name this. Let's call it netmap and then which version it is. So netmap naive.c. Like so, and the H file will be common for all the different versions. So let's just call this netmap.h. Like so, and did that update as well. Yes, and we need a make file for this as well. And this will be a little bit bigger since we are dealing with several different versions, but not much. It's very big. Okay, so let's do the same. We begin with the flags. I want O3, I want wall, I want standard. I'm going to speed through this a little bit. Standard C2X. LD flags, perhaps we're going to use those. By the way, I almost forgot. I didn't use the LD flags. We might want to do that. So let's add those so we don't forget it. There we go. Perhaps we should move this part. Yeah, I think so. We make LD flags out of these switches. Okay. In this case, we're not going to have any LD flags to begin with. We're going to link in our burst utils library, of course, but that'll be later. For now, let's just start with the nm naive.o, which will depend on nm naive.c. And we're going to run cc with some flags, and we're going to run -c and this source file. When we have an O, we can create the nm naive binary, which will depend on the nm naive.o. And we're going to run cc with some flags. And then we're going to take the source file and we're going to produce a target file and use our LD flags as well. And our all will use clean and then nm naive. And we also need to create that clean one. And I will just simply remove all the O files and nm naive like this. That ought to do it, I think. Yes, it compiles, but it can't link because we don't have a main. So, as expected. Okay, that was information and preparation. In the next section, we're going to start the actual coding of our tool. Alright, so let's see where we were. We have our make file, we don't have to worry about that anymore. And we can close this down as well to get some more space. Okay, so first of all, we need a couple of includes, and as usual, I'm gonna take the standard ones that I use in almost every project, and if we want later on, we can prune off if we don't use them. It's a better way, as I usually say, than to add one at a time when needed. It takes longer. And we need stdlib as well, and let's also use assert, and we need r number as well. I also want to have stdbool.h, and we need to define GNU source. I think we did that in the make file, but let's do it here as well, so we can use our assert p error. And I'm also going to create some data types, as I usually do. I'm going to do a type def for unsigned char, and this will be an int 8. I'm gonna type def unsigned short int to int 16, and I'm gonna type def unsigned int to int 32, like so. Right, so let's also create the function declarations. We're gonna have a main, and we're gonna use arguments, so let's do it like this, and we'll have int main with int argc and argv, and if argc is less than, let's see, we need 3 arguments, so if it's less than 5, let me think if this is right. So if we have 1 argument, this should be a 2. Okay, 4 then. If it's less than 4, we should error out. But we want to write the usage to the screen. So fprintf to standard error, and do usage %s, and let's see. We want to have the port first and foremost, so that should be compulsory. And then we want to have a start IP address. And let's do like this. And we also want to have an end IP address. And as you see, I have those in those kind of brackets, which means that those are not necessary to use. So let's change this to 2, because the port is the only thing we need. So if we supply a start IP address, let me show you here instead. So if we run netmap against port 22, and we give an IP address like this, a start IP address, but we don't give any ending IP address, then it will default to the last possible IP address. If we do give them a range like this, it will follow this range. And of course this ladder needs to be bigger than this, or at least as big. And we can also do something like this when we only supply the port, and then, as you might have guessed, it will read the IP addresses from the standard input instead. So you can basically do something like this, where we have an address file .txt that we put into this. Or another way would be simply to do something like cat address file .txt and pipe it to netmap. So we want the tool to be user-friendly, and adding those functions is quite easy, and it'll make for a better user experience. So I think it's important. Let's do a new line here, and also we need to send the argv. So this first argument of argv will be the name of the binary that we're executing. And then we will simply return -1 like this. Otherwise, return 0. Something like that. Does it compile? Let's see. Oh, what happened there? Oh, I forgot to include our own H file. So include, what did you call it? netmap.h. And now it compiled just fine. If we run it like this, it will give us the usage, and if we give it a port, it will not. Alright, nice. So how are we going to structure all of this? We do need to have a function which will calculate this range. And we also need to somehow generate the IP addresses. So, and that should be one of our utility functions. So basically that will be in our Birch utils library. So yeah, in order to go from this kind of format, the regular IP address format like this, to the numbered format that we're going to need when we connect, there is already a function in the standard library which is called inetaddress. So we'll use that one. But the other way, when we want to go back, then we need to create our own function. But perhaps we should wait a little bit with that and focus on the actual range first. So let's create some function which will, let's see, should we I think we're gonna make it a little bit easy for us. I'm not very fond of global variables, as you all know, but we are using C, procedural language, and we are allowed to have global variables. So let's at least have one for the current IP address. And which format is that in? Let's see. If we run this init address function, what does it return? Okay, an in address t. An in address t is a structure. Init make address. What is this? Have you ever seen this format before? So you do struct in address and then a function. Is this some kind of constructor function for structures? I need to Google that. C struct constructors. Object, no, this is the regular stuff. But what? Object, new compound literal. You see, it's supposed to declare an inline function with the same name as structure. Struct my int a, inline struct my int a, return struct my a. It really is a constructor function for structures in C. How can I have missed this? I think I'm going to make an episode about this later on when I have experimented a little bit with it. But it looks really cool, doesn't it? Sometimes you just stumble upon cool things like this. Alright, so that's basically how this is done then. They have an init make address, which is a constructor function which generates those in addresses. But this is what I was looking for. In address t will be our return type for the IP addresses, which makes it suitable as a type for our global variable. So let's create an, what did you call it? In address t. Was it? Yeah. And let's call this, where are we? Here. Let's call this current. So this will hold the current value of the IP address, and we will just simply increase this by 1 each time we want a new IP address. So I will create a generator function for that purpose. We do, however, also need an ending. But do we really need to have a global variable for that? No, I think I'm gonna pass that as a argument instead. But then we need to use that in very many different places. It's a bad habit, I think, that I'm getting used to using all these global variables, but let's do it. Okay, so we have a current and we have an ending. And let's see. We will create our generator function, and that will be of the same type in address t generate. Sorry. And we don't need to have any arguments then, since we're using the global variables. And what do we do here? Well, we take the current and we add 1 to it. And if current is more or equal to ending, let's see, no, then we will skip the last one. First we will check this, and if current is at the last IP address, then we want to return in address t of 0. Otherwise, we'll increase current and I know the else isn't necessary here, but I think the structure looks a little bit better. And then we'll return current, like so. This makes our lives a little bit easier. We should not forget to initialize those variables as well. So let me see the return of this inet address. What if it fails? How does it tell me? Standard attribute description. Where is the return value? Okay, if it returns 0. No, that's not it. If the input is invalid, in address none will be returned. Usually -1. Usually. Oh well. Let's use this then. So if it fails, then it will return in address none. And let's see, we will set current. First we need to find out if we even have 2 IP addresses. So if argc equals, let's see, 2, 3, 4, then we have both. Or maybe we should do if it is more than 2, then we at least have 1 IP address. So let's make a block out of this. So in this case, we at least have the first IP address. So we will set current equal to inet address argv2, like so. And if argc is more than 3, then we have an ending address as well. So then we can set ending equal to inet address argv3, like so. And if we don't, then we'll set ending equal to inet. Let's do this a little bit cleaner. Ending equals, okay, so if argc is more than 3, then we will return the inet address of arg3. Let's do it like this. And if we don't have that, we will return the inet address of 255, 255, 255, 255. Like so. Alright. Let's also do some sanity checking. Like if let's do this. If current is equal to this thing, or if ending is equal to this thing, or if ending is smaller than current. Then we'll do this again. And we return -1, like so. Alright. Looks okay. By the way, the inet address, do we need any includes for that? Yes, a couple. So let's put it inside of our C file. 1, 2, 3. No, let's do this. Boom, boom, boom. Okay. Let's see if it compiles. We can add some temporary stuff, by the way, so we see a little bit more what's happening. So if it succeeds, we can print out start %d and end %d. We're gonna send and perhaps we can just put it here without any casting. Current ending. If we can't, it will tell us, most definitely. All those semicolons. There we go. Alright, compiles. And if we just give it a port, then we don't have any start and end. if we give it a start IP address like this. Oh, no. Didn't quite like that, I think. What if we give it an ending as well? Okay, then it works. So these are the numeric versions of this, basically. But it did not work when we didn't give it an ending. It should default to this 255 fella. Ah, wait a second. This inet address none, it defaults to -1. And 255, 255, 255, 255, what is that? Well, it's -1. Okay, that's not too good. Let's check, where does the multicast addresses begin? Maybe we should only use real IP addresses. Let's see. Is it 192 something? Let's see. IP address classes. No, not private. Let's see. Private address range. Okay, so this is the last IP address before the multicast addresses. And this is private IP address, but perhaps you do want to scan private addresses, so we need to handle that. So let's see, 127. So, wait. First octet value range from 192 to 223. Okay. So this is basically the last one. Yeah. Alright. So instead of doing this 255 thing, let's use 223, 255, 255, 0. It's weird that it ends in a 0. I think I'm gonna do 254, 255 instead, right? Okay, so now it works. If we just give it an IP address, it will scan all the way up to the last real IP unicast address. Perfect. Perfect, perfect, perfect. Okay. So now we have a little basic structure. Let's create the generator, and that is, we don't need to do anything more with that. We do, however, want to remember to add that to our list of functions. So we will have an in address t of generate void, like so. So now we have the port. Perhaps we should save the port somewhere as well. let's do that. So what format do we want the port in? Let's make it an int16, I think. And let's call it port. And let's do it like this. And we add the port right here. And before that we will do port is equal to the int16 of argv1, like so. Okay guys, that's all for today. If you like this episode, please like and subscribe. I will begin recording the next episode today, probably. But before we end for today, I'm gonna show you one thing. We do have a chat server now, so if you go to chat.birch.com, port 9000, you can connect to our chat. So you put your nickname here, and you can have the same username. At this real name field, you put your YouTube name. So mine is Dr. Jonas Birch. And then you just click connect, and you will be connected to our server, and you can send messages to me and to the other subscribers and members. And if I don't reply directly, I might be doing something else, like recording an episode. But I will check the chat every now and then, the upcoming days. So please stay there, and we are having a competition currently. So check the topic inside of the channel, and you can win fine prizes. Okay, thank you guys for today, and take care everyone.